start recording. So yeah, we cannot, in this case, the answer is definitely not the root of 12 plus 75. Okay? It is not that. So you can put a little note on there, right? So we can't do the addition thing like we did this multiplication. Talk me through it now, step by step. What do you want to do? So we can simplify, you've already said root 12 would simplify to? No, as soon as you're going to a calculator, yeah? Okay, so let's do that. So root 12 is 4 times 3, which is root 4 times, so we are allowed to do it with multiplication, just not with adding. So that leaves me with, no, was it? 2. 2 times root 3. Okay? What about the root 75? Does that simplify? So 25 times 3. You'll notice something here. Maybe you will, maybe you won't. So that's root 25 times root 3. And what does that end up with? 5. So if I put my add back in place, 7 root 3. Do you get the link that I was just talking about before? So that is 7 root 3s. Alright, so we've got 2 root 3s, we've got 5 root 3s. If I add them together, I have 7 root 3s. So this number here, a number of root 3s, okay, you can add those together, but we don't add the root 3s. We say, right, I've got 2 of them, I've got 5 of them. Just like if I've got 2 x's and 5 x's, they add together to make. All right. So what you're looking for, right, when you do these ones, are this, well, say common variable. It's not a variable, it's a radical that is the same for each one. All right, so that we can end up adding amounts of those together. So kind of in other examples you've been doing on these web pages, if you've written them all down, you probably will already have simplified versions of root 180, root 245 already sorted. Okay, so there's not, hopefully if you've been writing them all down, you've got something to refer to. If you haven't, you won't. That one's the same as this one. Let's just have a quick look at this third one then. Any ideas? Does 8 root 2 simplify at all? Root 2 is... Remember, we're only trying to simplify the irrational part, yeah? The root 2, that's as low as 2 is a prime number. You can't split that any further. So 8 root 2 is where it's at. But 2 root 8, well, the clue is in the first part, so we're looking for something root 2. All right? What do you think? So 2 root 8 will be 2 times root 4 times 2, which is 2 times 2 times root 2. So actually that is 4 root 2s. And we've got 8 root 2s over here, and be careful because we are going to subtract. So the final answer is 4 root 2s. So just in case you're a highlighter user. So the root 8 became root 4 times 2, which became 2 root 2. Just in case you're wondering why there's suddenly a 4. Okay, because those two. Alright, how do you feel about those ones? Not too bad, easy enough. As long as you don't add the two radicals together, we're okay. Now the next one, so I've gone another couple of levels on, so for those of you that are pushing it along with it, you can move up to level 5, 6. I've not printed these out, so you're going to have to write down the examples in your book. Some of you are doing anyway, which is great. The next levels, well, I think this one's level 5. Is that where we're up to? So this one's level 5. Okay, so we've had lots of multiplication, we've had some addition, which was slightly different. We've now got some division. Any ideas what you think we could do? It's like any division, any fraction that we're trying to simplify. What do we look for in a fraction? Well, we can't do a common denominator because I've only got one denominator. I haven't got two fractions, but what you're thinking about is a common factor in the numerator and the denominator, right? So, what are we looking for then? Well, we've got a root 3. We're kind of hoping that there's going to be a root 3 in the numerator that we can divide through by. Okay? So let's have a look if we can. So root 27, what does that simplify to? Root, well, the clue is, so have we got a something times 3 to make 27? 9. Okay? So that gives me, so root 9 times root 3, which ends up being 3 root 3s. Okay? Now if I put it back into here, so we've now got, instead of root 27, we've got 3 root 3s divided by root 3. Right? And what do we do? What do you do? What do you get if you divide something by itself? 1. So this becomes, instead of 3 times root 3 divided by root 3, that's basically what we're saying here. Like, sorry, my notes are going to be a little bit all over the place by adding this, but this basically is 3 times root 3, but then divided by root 3. And what does times root 3 divided by root 3 end up being? 1, yeah? Right, root 3, so I end up actually doing 3 times 1, so I'm left with 3, okay? Now what you may well remember seeing is when you simplify, people just go, oh, you cross that and that out, and it just disappears. But I'm doing something
Has to be negative.
No, nothing to do with that. People do that, that's absolutely fine. You cross it out, right? You no longer need to consider it. But what's important, I had a question with my M5s the other day. We've done this a lot. And when he cancelled everything on the top, and there was something left in the denominator, he was then confused, and he thought, oh, well, I have to put a 0 on the top. But that's because he was crossing out to disappear, when in reality what's happening is you cross out and you leave a times 1 behind. Okay, so it's not just disappearing and magically vanishing into thin air. It is a root 3 divided by root 3, it becomes 3 times 1, rewriting it again. Right, so that bit becomes a times 1, so you're left with, when you multiply by 1, you don't really do it. Feel all right? Okay. Not going to do this one. I'm sure you can cope with that one. Root 36 divided by root 9 then. That's an interesting one. Any ideas what you would do for this one?
They're both square numbers.
They're both square numbers, so
That's
6 divided by 3, which equals 2. Don't need to do any of the messing around with radicals and surds, or it's just, don't forget, if you've got a square number, deal with it first, yeah? Take it out, don't try and split it, and recognize your square numbers. Right. I do have one more level to look at. How are you feeling at this stage though? If I do one more, is that okay, or are you going to be overloaded a little bit? Hey, we're all good? We're good to go?
Yeah, we're good.
Okay. This one, right, there's something we need to add to this one. So when you see this in an assessment or something, it will say, simplify by first rationalizing the denominator. So can you write that? This whole rationalizing the denominator is the important bit. All right, so you have to know what that means. I'll let you write that down. So currently the denominator, right, because it's a square root of a non-square number, this is an irrational number. Okay, that is an irrational number. So if it says simplify by rationalizing the denominator, it means you have to do something to it to make it a rational number. So basically it's going to be something that could be expressed as a fraction. Any ideas?
I believe the easiest way to solve the square root would be to square both numbers.
Okay. I like the idea. Not quite right. Half right. What he's doing is, I believe this is what he's doing, so I think he's doing, is, do you remember we did a section where if you square a square root, you just get the same number, yeah? So he's saying if you square the square root of 3, you get left with 3, right?
What I'm trying to do is have both of them be a whole number.
Yeah. You don't need both of them. That's important. They don't both need to be rational. Now here's the thing. Right, sorry, I'm going to add another little page in. Bear with me. Let's look at fractions in this way. 3 divided by 4. You don't need to write this down. I'm hoping this is just a recap. Can I write 3 divided by 4 in an equivalent way without changing its value? I could do 0.75. There's a problem with that if I try and use that root with irrational numbers. What is it?
Doesn't help at all.
It makes it, I have to round and everything, yeah? So using the decimal root is not. So can I write an equivalent fraction to 3 over 4? So a fraction of different numbers but has exactly the same value. So for instance, I've got a piece of cake. I've got a cake. Right, here's my cake. If I split it into 4 pieces, and I have 3 of those pieces, all right, I've got 3/4 of the cake, yeah? Can I split it up further without... Go on, say again.
6 over 8.
6 over 8. Why is it 6 out of 8? Well, if I split each piece further, I've still got exactly the same amount of cake, but I've got what looks like a different fraction. How did you do that? times the top and the bottom by 2. Now here's the thing with fractions. A lot of people want to do that when they want to multiply by 2. But if I have twice as much cake, I would actually have 6 out of 4 pieces. That's doubling it. But if I multiply both of them, I would have 6 out of 8. It's the same thing. Yeah? So if I multiply the numerator and the denominator by the same amount, I get the same thing. Now let me ask you this, Gordon.
Yeah.
Is this true?
No. Wait. That's 12 out of 16. That's true.
Rethink.
9 out of 16. No.
Right, so this is where we've got to be careful. Squaring, look, oh, I've done the same thing to the top and bottom. Fine. Well, it's not though, is it? Because squaring basically means, instead of squaring, I've multiplied the top one by 3, but the bottom one by 4. So I've done a different thing. So squaring, Gordon's idea, was not going to work, because that was going to change the value of the fraction. So here's the deal with the rationalize the denominator. We find an equivalent fraction, but we do it in such a way that doesn't change the value. So if I take 12 over root 3, well, I am going to do what Gordon suggested, and I'm going to square the bottom. So I'm going to multiply that by root 3. But what do I need to do to the top? Multiply by root 3. Now, what does that give me? So on the top is 12 root 3. What's the denominator now? 3. Good. Okay? What have I done to the denominator? It's in the title. I've rationalized it. 3 is a rational number. Root 3 is an irrational number. I've rationalized the denominator. Next step is, can I simplify it? How? 12 divided by 3 is 4. So I end up with 4 root 3. Now I don't have any denominator, which is nice. Right? That's not always going to be the case, but it is in this one. Right? Does that one make sense? Okay. So I could do another one of those with you, or if you're feeling okay, I can send you back to that website again to carry on working levels 4, 5, 6. How do you feel? Do you want to do another one of either, or one more? Which one of these two would you like to do? The which one? The bottom one. Okay. All right. Excuse me. What should we do then? Root. Oh, you're doing this one. I thought we were doing that one. So root 5. So we're going to times that by root 5, and we're going to times the top by root 5. Okay. What does that give me currently? Well, I'm now at 5, root 15, root 5, all over 5. Well, that's quite nice, isn't it, so far? Because the 5 divided by 5 leaves me with the 1. So I've now got just root 15 times root 5. Can I do anything with that?
Yeah.
I'm just going to give myself some space here. Nope. Well, yes, but that's not a simplified answer. Is it? Why? It's not. I was just wondering why. Any ideas what we do with this one? This is back to our basics. This is back to the first level, or second level.
You put them together.
Well, that's what Gordon did. He went, put them together, you get root 75, but we then have to simplify that. We've just done root 75 in the previous question. So let's try and do it. Can I simplify? Well, first off, if I can get another root 5, well, what about saying this is root 3 times root 5? Now, that's slightly different because neither of them are square numbers, but I have spotted, look, that if it's root 3 times root 5 times another root 5, what does this become?
1.
That's 5. Okay? So the whole thing ends up being 5 root 3. Now, just so I don't kind of not what Gordon said on here completely, if we'd have done root 15 times 5 to make root 75, what would you have then done? You'd have done root 25 times 3, which is root 25 times root 3, which is 5 root 3. We'd have got there anyway, all right? I just didn't want to stop at the root 75. So you can see how some of these questions, although that first step is not challenging really, the difficulty is actually spotting, I have to do another step and then another step to get the simplest possible answer. How do you feel about that? All right? Okay.